Hello everybody, it's Nick from the Peoria Riverfront Museum. Thought I'd do a science video for you on this Thursday morning. Happy Thursday. Behind me I have a big heavy-duty thermos. It's actually called a Dewar, named after Mr. Dewar, who invented it over 100 years ago. And inside, in the middle, hopefully, we have some nitrogen left over. This is the gas that's all around us. Besides oxygen, it's mostly nitrogen that we're breathing in, breathing out all the time, walking through it all the time. And just like anything, if you get it cold enough, it'll turn into a liquid. And we went over to Peoria Air Gas on Adams Street, and they make liquid nitrogen, liquid oxygen, liquid argon. Really, really cold stuff. It's negative 320 degrees. And to keep it cold in there, to keep it from boiling away in a day, it's insulated by a vacuum, by nothing. So a space without any air in it between the nitrogen in the middle and the outside layer here. So hopefully there's still some nitrogen left. We'll try to get it out using the pressure of the nitrogen gas that's already inside there. There's a straw, just like when you drink out of a straw, the air pressure pushes the liquid up the straw and into your mouth. Well, the nitrogen gas that's already in there, that's boiled away already, will hopefully be able to push the liquid nitrogen up the straw, and we'll open a little valve over here and let it pour out into this cup. And we'll take a look at the liquid nitrogen. All right, here we go. And immediately you can see condensation. This is not nitrogen, this is water vapor, which is floating around the atmosphere, the lower atmosphere where we are all the time. When it gets up high enough in the sky, it gets cold enough, it can condense into liquid droplets. Here, it's so cold, again, the nitrogen is 320 below zero, about 400 degrees colder than it is in this room, that the water vapor around the nozzle here is condensing immediately, making a cloud, a cold, heavy cloud that's falling down, and pretty soon when we look at this later, it'll be so cold we'll see frost. So we'll look at that at the end. Right now let's look at the liquid nitrogen, which is boiling hot from the point of view of the nitrogen. So water boils at about 212 degrees Fahrenheit. The liquid nitrogen is boiling at negative 320 degrees, super duper cold. However, there's a really cool effect that will allow me to appear to touch the nitrogen directly, although I won't. It's something called the Leidenfrost effect, and it's named after Mr. Leidenfrost, who wrote about it hundreds of years ago, actually about water, boiling hot water, or water touching something really, really hot. And what happens is, when this liquid nitrogen touches a warmer surface, 400 degrees hotter than the nitrogen itself, the part that touches it immediately boils into gas. And so, if I were to touch the liquid directly, it would conduct heat away from my hand, and very shortly I could do permanent damage to the skin on my hand. However, if I put my hand in there just briefly, like a second, instead of actually touching the liquid nitrogen directly, I will be insulated, my hand will be insulated by a layer of gas, as the nitrogen around my hand will immediately turn into gas, which does not conduct heat as well, and so I will be safe for a moment, a second. So I'll go ahead and, just for a second, stick my hand into the liquid nitrogen, and out again, and I'm fine. So I didn't actually directly touch the liquid nitrogen, even though I put my hand completely, or my fingers submerged in the liquid nitrogen. They were insulated by the gas. There's actually a cool Mythbusters video you can look up on YouTube, where they do a similar thing where they get their hands wet and put their hands in molten steel for a brief moment, and they're protected by the same effect. Now because of that, when I pour some of this out, I'm going to pour some out here on the table, on this tray, the nitrogen is not going to pool as a liquid, it's actually going to touch the tray, and the bottom part of it will immediately turn into gas. And so it will start floating around, the liquid will float around on its own gas. It'll be like an air hockey puck, where you have air pushing up through the little holes and the hockey puck can float, and there's very little friction. So I'll go ahead and pour some in the tray, and we'll watch it bounce around, floating around, congealing, acting like there's no friction because it is floating on its own gas. And as it turns into gas, some jets are going this way, some are going that way. It bounces all around. Eventually it'll all boil away. In fact, there's so little of it there, I can safely touch it, turn some of it into gas, and I don't even feel cold because it takes very little heat from my finger there to turn it into gas. You can play a little game, whack-a-mole with the nitrogen. All right, now to get rid of the rest of this nitrogen, we could just let it sit here and it would boil away, and I don't know, maybe an hour it'd be gone. We're going to get rid of it more dramatically by increasing the surface area. It's only boiling essentially from the top. We're going to increase the surface area by throwing it all out of the cup at once for our dramatic finale. I'll throw it against the wall and it will disappear into the air. We'll do a little countdown. 3, 2, 1. And it's gone. We're left with a cloud. You can now see the frost that is forming on the nozzle of the dewar. That's just, again, water vapor. First we saw it turning into little liquid droplets making clouds. Now we see it turning into solid snow forming on the nozzle. And we've got maybe some more liquid nitrogen. We can do some more experiments in the future. If you have any ideas for what we should put in the liquid nitrogen or do with the liquid nitrogen, let us know. Let us know if you have any questions about the liquid nitrogen. We've got some other cool science stuff we'll be sharing with you in the future, other short science videos. So thanks for joining me on this Thursday, and thanks to all the museum members and Visionary Society members who helped make this kind of programming possible. Even with the physical museum shut down, we can still come at you with the virtual Peoria Riverfront Museum. Thanks, everybody.